In this video we're going to look at just a short video which summarizes section 7.1 and section 9.6, which is a section which talks about how to find derivatives of, say, a function f of x, and section 9.6, which discusses using the derivative f prime of x in an approximation problem. So this is what the subject of this quick video is supposed to do. So in section 7.1 we learned that if you are given a function f of x, let's say that you're given a function f of x, and then you put in x plus h into this function, you will find that f of x plus h, if you expand it using algebra, that what you will find is that f of x plus h will expand to f of x plus something times h plus some terms h squared, h cubed, and so on. And it's the expression in front of the h term that is what's important to you. This f prime of x, the function that's in front of the h, is called the derivative of the function f of x. And for the most of the functions that we are looking at, so for example 2x squared is your function. If you compute f of x plus h, you will get 2 times x plus h squared. If you do the expand step, you will get x squared plus 2xh plus h squared. If you expand it, distribute the 2 to get 4xh plus 2h squared. And as promised, 2x squared was your function f of x. 4x is the function in front of the h term, and it is the 4x, which is what we are calling f prime of x. That's called 4x. 4x is called the derivative of the function f of x is equal to 2x squared. Okay, and it's this root that will lead you to the derivative of a function x to the n. If you do this process, f of x plus h, and expand, you'll get f of x, which will be x to the n, x to the n plus h. And if you expand this, you'll get nx to the n minus 1 times h plus some stuff, and the function in front of the h term is the derivative. Okay, so this is the first step that it's important for you to know how to find the derivative of a function using this approximation method. So the method that I'm using here is called I'm using the linear approximation method to find f prime of x. And this is a good method when your functions are nice and simple, like linear functions mx plus b. Okay, quadratic functions like q of x is equal to ax squared plus bx plus c, quadratics. And these are the majority of the functions. These are the most used functions in business math. So this method I'm showing is it's robust enough and useful enough to find the derivatives for the functions in section 7.1. Okay. The other thing that we will use is the function f of x. Say that your function is two functions added to each other. F of x is g of x plus h of, oops, sorry, maybe I shouldn't use h. Let's say that g and q are p of x. We'll say the second function is p of x. So if you want to know what the derivative of this function is, what's the derivative of two functions added to each other? Well, you'll compute f of x plus h which is g of x plus h plus p of x plus h. Okay. And g of x plus h is going to be g of x plus g prime of x times h, approximately. P of x plus h is p of x plus p prime of x times h, approximately. Okay, p and g go back together, p of x plus g of x. Both of these terms have an h in them, so you can factor out the h, and you'll get g prime of x plus p prime of x. And what we have shown here is that if your function is two functions added to each other, then you know that the derivative is going to be g prime of x, the derivative of the first function, added to the derivative of the second function. So for example, what you could have here is, say, if f of x is 2x added to 3x squared, this 2 would be your function g of x, 3x squared would be your function p of x. So f prime of x is 2 plus 6x. Here is g prime of x using the power rule we just discussed, and this would be 6x, which is p prime of x. So we have the two derivatives added to each other. The last thing you would need for this section, so what we are doing is the derivative using the linear approximation method. That is the method that I am doing in this section. So section 9.6 is basically just utilizing the formula. It's just focusing on the formula f of x plus h is approximately f of x plus f prime of x times h. And there is another YouTube video you can watch on the approximations, but essentially the key example here for is essentially that if f of x, let's say your function f of x is the square root function, and you've been asked to find the function evaluated at 4.1, so that would be the square root of 4.1. Now you can use your calculator, but the idea here is that the function evaluated at 4 plus 1, this is the function evaluated at 4 plus 0.1, right? So x is equal to 4 and h is equal to 0.1. The idea here is that this the square root of 4.1 is approximately the function evaluated at 4 plus f prime of 4 times 0.1. The function evaluated at 4 is the square root of 4. I need the derivative of my square root function at 4, and then I need to multiply that by 0.1. Okay, but from the power rule, f prime of x, that would be the derivative of the square root of x. Square root of x is x to the 1/2 power. So the power rule, right, says that the derivative will be 1/2 x to the negative 1/2, or 1 over 2 square root of x. So f prime of 4 is 1 over 2 square root of 4, which is 1 over 2 times 2, which is 1 over 4. So what we know here is that the function evaluated at 4 is the square root of 4, which is 2. We know that f prime of 4 is 1/4 multiplied by 0.1. 0.1 is the same thing as a tenth. So that would be 2 plus 1 over 40. So that is your answer to the function evaluated at 4.1, which is the square root of 4.1, is approximately 2 plus 1 over 40. And that's how you use this derivative formula, the approximation formula, to answer an approximation problem. Okay. So that should end this video on just kind of showing how sections 9.6 and 7.1 go together. The key idea is that if you use the linear approximation method to find the derivative do the expansion here. Do the expansion for f of x plus h, and that will lead you to a formula for f prime. Once you have f prime, you can use this idea in the linear approximation problem to approximate a function, say square root of x, in this case the square root of 4.1, at a particular value of x, which is 4, and you can use this star formula right here. So that would be just a quick video on showing how Professor Osborne is using his the linear approximation method to do derivatives and approximations.